Thank you very much for joining to this training, Help Corals Get Trained in Tracking Coral Bleaching Events. It's lovely to see so many participants and people interested. Next slide. So my name is Andrea Rivera Sosa, and I work as a project and outreach manager for the Coral Reef Alliance and also the Allen Coral Atlas. And we'll be having some technical support, which we need today from Ben Sharrow, program coordinator with the Global Conservation Science team at Coral, and who will be intervening in the Q&A section. So this presentation is the result of a brilliant collaboration among the Allen Coral Atlas, ReefCheck, Wildlife Conservation Society, the Mermaid platform, the School of Earth and Environmental Science from the University of Queensland, also Reef Cloud, a software developed by the Australian Institute of Marine Science and the Australian government. So these are some of the people behind the organizations. Here with us today, we have Helen Fox. We have from the Coral Reef Alliance, we have Manuel Gonzalez Rivero from Reef Cloud, Ames, and we have also Chris Rolfsema from the University of Queensland. Thank you very much for joining in today. And they'll also be helping out with some questions at the end. We'll make sure that we give them the hard ones that we get for each of the methods. So before we get started, I'd like to ask you a few questions to get to know you a little bit more. So let me launch a quick poll to know more about your bleaching experience and also to know what area you're more than likely to monitor coral bleaching. So we see that the answers are coming in. Thank you very much. I'm very curious to see the answers. And then give it one more minute to get everybody's responses. We have about 85 participants joining us today. All right, so I think we have pretty much everybody's responses. So it seems like the majority, or it keeps on changing, about 60% are preparing for their first bleaching event, and about 32% have been in 1 or 5 bleaching events before, so have some experience, and then a lower percent, 11, that have been into 5 or more bleaching events. And so the regions most likely to conduct the bleaching surveys, Indo-Pacific has about 60%, followed by the Atlantic and the Caribbean. So these folks are staying up late today. And we have Australia, 16%, and Western Indian Ocean and the Persian Gulf with 5%. So thank you. All right, we're gonna end the poll. And sorry, I think I didn't share it before, but I think I just told you the results. Okay, so the overview of this training is to give you a general introduction to coral bleaching and the Allen Coral Atlas. Also some general guidance for coral bleaching field surveys. And then we're going to cover 3 different methods and data platforms: the Belt Transect from ReefCheck and the Global Reef Tracker, the Rapid Bleaching Protocol from WCS and Mermaid, and the georeference photo quadrats and Reef Cloud. And we'll end the session with the Q&A, so we'll be able to answer some questions. And also feel free to send the questions along the presentation through the Q&A. and we'll respond them at the end. Thank you. So coral reefs are a critical marine ecosystem. They host 25% of marine species from only 0.1% of the surface of the ocean. And coral reefs provide yet so many services to humans. As you can see in the next click. Yet, on the next slide, you can see that they're at risk from serious decline from local threats, but also from global threats such as climate change. And the facts are clear. The world is getting warmer, and it's because of us. 97% of publishing climate scientists agree that global climate change is real, and it's a result of human activity. So the increase in marine heat waves is causing more recurring and more extreme coral bleaching events. Using Australia's Great Barrier Reef as an example, we can observe in this graph how over the last 4 decades, the GBR has been hit with massive bleaching episodes, being this year the 6th event. A recent study by Spatty et al. Mentions how this year, 2022, represented more accumulated stress than ever before and during the summer period for the GBR, and its first mass coral bleaching event to occur during La Nina year, which usually brings cooler water. So the projections for this year's, yes, next slide, it's fine. Bleaching alert from January to April, we have seen an increase in bleaching alerts and sea surface temperatures. Here's a graph provided by NOAA. And you can see the temps starting increasing in February, then escalating. So they start increasing in February, escalating in March, and then start reducing again in April. However, in the next slide, you see that projections from April to July this year do not look good for the Pacific. And it's important to start activating the networks in this region. So we thank you for being part of the training today. So in the next slide, we have seen that marine heat waves increase, massive bleaching events can unfold and can impact large-scale reef areas if stress is prolonged and suffer mortality. So coral bleaching can occur when corals become stressed. So next slide. From high or low water temperatures or other factors such as changes in water quality, light exposure, or tides. And this stress causes the symbiotic algae to produce an excess in oxygen, resulting in the buildup of toxic waste products. So the coral host expels the symbiotic algae, leaving the coral bleached white without its built-in production source. And bleaching is complex, and many intrinsic factors like those in blue and many external factors like those in gray can have an influence. But for this training, we'll focus on bleaching triggered from heat stress exposure. So now shifting scales from symbionts to satellites, the Allen Coral Atlas has recently launched a bleaching monitoring system to help track coral bleaching events in near real time to help conservation research and education initiatives. So this monitoring system in the next slide, you'll see uses satellite imagery available from 2021 at a 10-meter resolution. It's also available globally for all shallow coral reef areas that have been mapped in the atlas. And we hope that throughout this training, you will learn different survey methods to collaborate and help validate and strengthen the tool. The bleaching monitoring system starts processing satellite images when a region enters a NOAA bleaching alert due to the warming waters. And then the atlas measures the bottom reflectance or the brightness of coral reefs in alerted areas in bi-weekly periods until there is no stress. And it does this by defining a baseline color or bottom reflectance of a reef area during periods of colder water, which are usually 3 to 4 months, and then compares the brightness of reef areas during warmer water. So as temperatures continue to rise, corals, as you know, may bleach, and this can be observed in the change in brightening over the reflectance values. So the difference in brightening can be observed in 3 bleaching categories based on the number of weeks that brightening or reflectance has occurred. And they range from low, moderate to severe. And if you'd like to learn more, I invite you to explore the bleaching tool in the next slide. So you can see the Allen Core Atlas website. Our tool is in beta stage, and all the bleaching feedback that users like you can provide is extremely important. So moving along the training, I like to provide you with some general guidance for coral bleaching field surveys. So the first one is site selection. Perhaps you already have set sites or you're establishing new ones, but it's important to identify the type of habitat where you're surveying and to include replicates of the shallow and deeper sites. And note if they're exposed or shelter sites from wave exposure. So for the Atlas verification purpose, we can only review areas up to 10-meter deep, but for general bleaching understanding, it's important to know how corals in deeper waters are being affected. And of course, within selecting the sites, safety and site accessibility must also come first. So the second very important one, and I know that Chris can talk a little bit more about this, but it's very important to georeference the site as best as possible. So many GPS locations are taken from the boat rather than the site you survey. And this is a very big problem. And it's an issue because one of the main requirements for using field data to validate satellite-based products is that each field data point collected has an actual GPS coordinate. So a GPS position should be taken to represent the site as best as possible. And this can be done with a GPS on a float, which we will cover more in detail in the georeference photo quadrat section. But I will also give you some tips on how to do this in each of the methods. So the third one is to survey corals during peak bleaching events. And this is ideally 21 to 30 days post-peak degree heating weeks. So the surveys may not be representative if they're done too early or too late. So the timing of the peak bleaching season varies among ocean basins and hemispheres, but it's generally during the local summertime. So for example, the peak season is July through October in the Northern Atlantic and Pacific Oceans, and January to March for the Southern Atlantic and Pacific. And the peak is April to June for the Northern Indian Ocean and January to April for the Southern Indian Oceans. Also, if you're able to survey corals 2 to 3 months after bleaching peak to assess recovery or mortality, it's also a good thing to plan for. So the fourth one is to note that coral bleaching can also be colorful, and not all coral bleaching is white. This has been observed all over the world, so it's important to be aware of the normal colorations of the corals in the areas that you monitor. And this very neon and bright coloration is thought to act as a sunscreen that may aid in the symbiont recolonization. Okay. Also, some corals can naturally appear white, pale, or with lighter parts. This is the case of Montastra cavernosa, which has a variety of pigments in the Caribbean, for example, including a white phenotype that is normal. And it was once thought that it was bleach, but it's an actual normal coloration. So other species tend to have white growth tips that lack pigmentation, like Acroporas, or others that have white bumps, like Orbicelas. So be aware of this so that bleaching is not overestimated. Also, it's important to be able to distinguish recent mortality versus bleaching. So sometimes when we're out surveying, we see a white coral right away and we think that it's bleached. But beware the new mortality where the bare skeleton can be observed. Could be due to predator bites such as fish, snails, fireworms, crown of thorns, and could be also mortality from bleaching itself. So usually when there's bleaching, you can see the live tissue still there and not the bare skeleton. Some other corals may appear white from coral diseases, so make sure that you take note of that. So now moving on to the section that everybody's been waiting for, the survey methods and data platform section. We know that there's many ways to survey coral conditions and that we're only going to cover a few today. But through this training, we will cover a snapshots of a few method types which have higher taxonomic resolution. You can see the A and B, the diver and the photo. And these methods will allow us for further validation of the satellite-based readings that we see shown in the E icon. And so to start off, as a roadmap, we'll start with ReefCheck, which is a citizen science program, which surveys focus mostly on the marine ecosystem as a whole, and the method is quite general. Then we'll cover the rapid bleaching protocol, which assesses corals at the genus level, also growth forms. And its primary goal is coral bleaching assessments focus. And then we'll cover the georeference photo quadrat and Reef Cloud, that required a little bit more technology than the other, at least 1 to 2 cameras and 2 GPS. And this method is the method that provides more spatial precision on benthic coverage. So let's start with the belt transect from ReefCheck and the Global Reef Tracker. This was founded in '97, and this method requires additional training and testing in order to obtain the EcoDiver certification. It's present in 40 countries and has trained more than 7,000 citizen scientists. So in the next slide, we'll see that the method combines 4 main components into a 100-meter transect. It applies a point intercept transect for benthic cover and also a belt transect for mobile invertebrates and bleaching. And this survey is called the Invertebrate and Impact Survey that we'll talk a little bit as we move forward. So if we go back just one moment, we'll see that the 100-meter line, transect line, is separated into 4 independent 20-meter transects, which are separated by 5 meters. So ideally, the best location to have georeference in this method would be the middle of the transects. So in the next slide, to talk a little bit about the substrate survey, this survey doesn't look at bleaching specifically, but it's quite important because it looks at the major substrate types and benthic organisms. So it uses point sampling at 50 centimeters intervals with a plumb line. And that way we're able to have benthic cover estimates. So now the next one is the invertebrate and impact survey. And it does record bleaching in a belt transect, which is 5 meters wide and 2.5 meters wide at each side of the transects. And for this method, if bleaching is present, 2 estimates are made on the percent coral cover. And these are done on the percent of the coral of the total population and the percent of colonies. So first, teams estimate the percentage of all corals during the transects that are bleached. And then second, they estimate the mean percent of each individual colonies that are bleached. So for example, we can assume that there's 10 corals and that 3 of those are bleached. So that would be 30% of that population of that transect. And then within those colonies, a mean percent of all the colonies are assessed. So let's say that only 25% of those colonies were affected. So that would be the number that would be recorded. And that would be done in the next data sheet that you can observe in the green box. So the bleaching percent of coral total population is done for every transect of 20 meters, and then the bleaching percent of colony as well. So the data sheets are available for these different regions, and they're available online on their webpage. So once you have the data, you can enter the data and email it to the ReefCheck's coordinator, or you can also enter it in Mermaid. However, there's a new platform that is currently under construction that will allow the upload of the data onto the platform. So stay tuned for that. So now we will continue to the rapid bleaching protocol from WCS and Mermaid. So this protocol is conducted via diving or snorkeling, and it's a roving method. So there's no need to lay out a transect line. It's a visual assessment of a quadrat from 1 to 2 meters squared. And usually it allows for a total of 15 to 20 quadrats per survey per diver snorkel. And within each quadrat, you identify the colonies to a genus or also to growth forms, and you score them into 7 categories of bleaching severity, which we'll see coming up. And then also when you visually estimate, thank you. Then you visually estimate the percent cover of hard coral, soft coral, and macroalgae. And so this method was developed by McClanahan and Darling for the 2016 bleaching event. And then we have Mermaid, which is an open source application that collects and manages real-time data for coral reef health. So in the next slide, if you're in the Pacific and Indian Ocean, in your quadrat, you would identify up to the genus level or growth forms. And if you're in the Caribbean, you could do up to the species level category and also genus or growth forms. And if you do select genus, then you record the following 7 bleaching categories. And if you select the growth form, the categories become much simpler. But here you can see the 7 different bleaching categories. So when you're out in the field, next slide, you start with this sample underwater data sheet or your slate. And you have your genus identified, you have your categories and your different percentages, and you also have the recently dead category. So what you do is through each of the quadrats that you are assessing, you are practically tallying each of those genus. And if you choose the next growth form option, then you write down the growth forms, and then you have a simpler categories: normal, pale, bleach, and recently dead. And you do the same. You tally the number of colonies with the growth forms that you see from each of the quadrats. And from the quadrats, you also identify other information. If you, yes, and so on your slate, you'll see that you can put numbers of quadrats and then the percentage that you see of hard coral cover, soft coral cover, and macroalgae cover. And then this will tell you the number of quadrats that you have assessed. So you're moving along after your 3 quick swims, and ideally for this method, you would have your GPS coordinate from either at the start and end, or in the middle of where all the quadrats were taken to have a more accurate estimate of the location. So now you've collected all your data and you're already ready to input into the Mermaid. This is the Marine Ecological Research Management Aid. And next slide shows that it has a global platform, and you can see that the dashboard has a summary of the countries, the projects, the sites, and the general trends of the information that has been submitted. And then in the next slide, first, you start with your with signing up and setting up your project. Here you can define the users that you also would like to include from your team, and you can prepare this for offline use. I like this quality because we know that we don't have the best internet in all locations. So this allows you to input the data offline as well. So next, you will see that you can collect the data either online or offline, and then you enter all the site specifics for your location, your Transect information, and then you save each individual one. Then you validate and you check the information and you submit it to make sure before that, you run quality control to make sure there's no errors, and then you can submit the data. Next, you'll see that you can export the data either in for further analysis in a Excel or in a CSV format. And then what you can see is that you can have other data that can be complementary. Maybe you also have fish felt transects, and then you'll see here more information on the coral bleaching component. So here you can see what the platform looks like. First, you have to select the quadrat size, add the observer, and then there's other details that you can also complement with: the visibility, depth, currents, or tides. And then you continue further down. It's basically one frame of information where you can put your benthic attribute, if it was the genus. You can also put the growth form, and then the different information for each of the categories: pale, bleached, with the different categories, and then recently dead. So in the bottom part, you're able to observe your final total numbers, and you can save the information and you can download it. So yes, usually, and I didn't include this, but you're able to visualize the information on a dashboard that shows you the satellite imagery of where you've done your site, and also a summary graph of the information that you have just inputted. So it helps you create graphs of the information that you just created. So now we'll move on to the next method, the georeference photo quadrat method, and the Reef Cloud platform. So this method can be done via snorkeling or diving. It can cover up to 200 meters up to a kilometer, and that's a lot of swimming. And it's important to note that it does need additional photo GPS linking software, and this is available through University of Queensland, and there's different specific protocols and manuals on how to sync the equipment. Each photo is a data point that can be tracked, and this method is used to train and to validate the Allen Core Atlas habitat maps, and now most recently also the bleaching. And it uses also, it can be, it works together with either CoralNet or Reef Cloud. Reef Cloud is a recently launched program. I think it was just launched last week. So congratulations. And this is a new photo analysis software which uses machine learning also to help train the algorithms to help identify different benthic attributes. So then the next slide, you'll see some of the items and requirements that you need for the georeference photo quadrats. And to start, you need to prepare the GPS and the camera settings for calibration. And as I mentioned before, this is all carefully explained in a technical protocol that must be followed. First, to calibrate the camera, you need a plumb bob, and you need to calibrate a 1 meter squared imaginary quadrat. So you can do this with already a quadrat established, or also with paper. Then you need to sync the camera and the GPS. So you do this by taking a picture of the GPS and doing some previously settings on the GPS that you will be using on the float for the surveys. And you have to make sure that you have a good dry bag, and you can also use some weights to stabilize the float once you're moving along, either swimming or snorkeling. Something very important, dry runs are required to ensure that the equipment is properly synced. And there is also some previous planning that you need to do when you do select the sites, depending on the direction that you're going on the Transect. And you also need to coordinate with the dive boat captains on if you're going north, if you're going south. So in the next slide, shows a little diver with the GPS float and taking a photo already calibrated with the plumb bob at a 1 meter. And before doing this, you start with a photograph of your slate where you put the date, the start time, the site name. So there's no data sheet necessary, but you have your slate with information. And then you start swimming along with a set direction that you already established, and you start taking photos in about every 2 to 4 kick cycles. So that gives you approximately 3 meters in distance. And most of the photos, or all the photos, need to be facing down at the same distance, using the plumb bob as the reference. So next slide, some tips on the photos. Ideally, you have your camera set in underwater mode, and there's also some other criteria to have the best high quality image. Also, if you have a red filter, it helps remove some of the greenness of the images. Ideally, you like to move slowly, face the camera downward, as mentioned, to keep the distance consistent, and important to be able to distinguish the survey. So always taking a picture of the start and the end so that you know which side is which, because in the end you end up with about 200 to 500 pictures, and so it's important that you keep these segments separate. So these are just some images of 3 or 4 good pictures on the top and some really bad pictures on the bottom. Next slide. This is what it looks like when a diver is taking some photo quadrats and with the plumb bob, and what the photo quadrats look like of the reef. And then here's another person doing a snorkel. Yep. And we can go on to the next slide. So this is my favorite part, when you've done things correctly and you can link the photos to the GPS coordinates. So you do this with the particular software that I mentioned, and you download the photos, you relabel them, you organize them, and you link them to the GPS. So once the photos are renamed and are have a proper GPS position, usually the software can give you an output of a KML file that you can upload onto Google Earth, for example, and you can see when you click any of these points, you can see that the picture of the photo quadrant. So if you click, Ben, you'll be able to see that you can connect to each of the individual points. It's an actual photo georeference of the track that you have followed. So once you get to this point, you can move on to derive the benthic cover data and the bleaching data using Reef Cloud. So once we're in Reef Cloud, this helps you manage the images, all the images that you have. It helps you analyze manually and also with AI, and it can automate the analysis and reporting. So to do this, you start off with creating an account and setting up a project and users to your team. Then you collect the images that you already have, you add the surveys to your site, you upload them, and you review your images to make sure that you only have photo quadrats and not pictures of reefscapes or people. You should already have that cleaned up beforehand. And then you go on to the process of training the algorithms, analyzing the images and training the algorithm and validating the results. So once you get the results, you're able to export them for further analysis, and you can share with your team. And also, if you want to make the information public, you can share it to the world. So next slide. This is what the Reef Cloud platform looks like. You can create a new project. This is a site that has already many different projects, Fiji, Caribbean, and you can also edit existing projects, like adding new sites to each of those locations. In the next slide, you can see, and my internet, so you can see the images and select also how many different images. So some organizations use 5 points, some organizations use 10, some others even more. And you can also assign different labels. So in this gray box, if you can click, Ben, you'll be able to see, for example, 15 simple benthic classes. And this is, for example, the classes needed for the verification maps of the atlas. Adding here the bleached hard coral cover category, but you can get as specific as you want in your study. So here, for example, you have many different attributes of coral forms. And what I like about Reef Cloud is that you can be specific, but also reanalyze your information to become more general in your labels. And the next slide. This is what the dashboard looks like. Then once you have inputted the information, you can see where the site locations are. And you can also have graphs already made of the, for example, hard coral cover over time, depending on the information that you have. And this is also available online. And to finalize the training, I'd like to finish off with 5 guides, 5-step guides to coral bleaching response. And we'll do this before moving on to the Q&A section. So this is a 5-step summary guide that that we have covered in the training. And to be able to respond to a bleaching event, and that can be done anywhere in the world. So the first step is to identify a monitoring program. Here we've seen 3 different ones, and also to review satellite-based warning systems. We saw the Allen Core Atlas and the NOAA systems. So the second one, now I'm ready for the second one, is to learn a survey method, which will allow you to prepare, train, and learn a method in the water as well. So today you learned about 3 different types: the belt transect, which you can click, also the visual quadrats, which you can click, and the georeference photo quadrats. So in the next 3rd step is to be prepared to respond. This is a very important one because here you need to secure funding, the tools that you need, the proper sampling, identification of the sites, and also very important, a general strategy to reduce the stressors. So depending on the level of involvement that you have, with other coral reef conservation organizations, you can link up with them to do this. So for example, some locations close sites to tourism, or they further enhance already present regulations. And the 4th one is the implementation of surveys and data collection. So we apply this also in this moment, the stress reduction stressors, and then you are in the process of monitoring the coral bleaching event. And the final and 5th one is to do the data synthesis and validation. So you can input the data collected into platforms. We already saw 3 different ways, 3 different types, and the data can be used to inform the status of bleaching to decision makers, but also your data can help validate the Allen Core Atlas bleaching detection tool as well. So thank you for listening. We have now reached the Q&A section. and Ben is going to help moderate this section. Thank you, Ben.
No problem. All right. So yeah, feel free to plop your questions into the Q&A or the chat, and we'll be looking for them. But the Q&A, I think, being the preferred. So we have one question that's come in so far from Ahmed, and they ask, how can we use the data for coral conservation on the ground, as we can't stop the stress of high temperature?
That's a very good question. And as I was mentioning, the third step about applying stress reduction strategies, I think it's very important to, we don't want to further go on the doom and gloom situation with coral bleaching, but we want to be able to monitor and show the information to be able to feed onto these global platforms that can transform the information to policymakers to really assess the situation that we're in. So I think that's one of the main ones, because many times our monitoring efforts are done very scattered. And sometimes when we do things in collaboration and together, I think we can send a better message to our policymakers.
Let's see, we have another question, this one from the chat. I am wondering to know why there is a 5-meter gap in the belt transect method, from Masa Salini.
Okay, and that's a good question. So the ReefCheck methodology does this to make those transects independent transects, but at the same time it helps you save time, because you're laying out the 100-meter transect and you're working as a team with others who are monitoring other things, fish. Some are doing the benthic transect, so it allows for more coordinations of the teams to be together, but at the same time that 5-meter separation allows for independent transects.
Sounds good. We have another question coming in from the Netherlands. This person asks, I'm using different tools for different methods. How can we check where to go so we don't survey regions that have already been surveyed?
Okay, that's a good question. So one of the benefits of having this information be linked to data platforms is that you can go back to these platforms to check what locations have been surveyed. So for example, you can go to Mermaid and see what areas have been monitored using WCS. If you go to the Reef Cloud platform, you can see what areas have been monitored using photo quadrats. And so it gives you more of an idea of what areas might have gaps of information.
All right. The next question, why is the peak season July onwards in the Pacific?
Okay, this is about the different bleaching peaks. Okay, so I took those bleaching suggestions from the NOAA platform. I know that with climate change and as the years move due to extreme sea surface temperatures, those bleaching windows are changing, but I think that those were the the general bleaching windows that were provided by the assessment from 30 years of temperature from NOAA. And those are very, very general. So they can vary depending on the locations where you are. I'm trying to search, yeah, where I found it from, but it is the NOAA website.
Great. Okay. Next question. For the georeferenced photo quadrant, what can we do if there is a strong current and the buoy will not align with the diagram?
Okay, that's a very good question. That does happen when you have a strong current. So what you could do is, depending on your depth, also you have to be careful because you want to keep a constant depth, and you want to allow a certain tightness of the reel. You don't want to give it too much reel, but at the same time, you don't want to keep it too tight. I think what I've found that's very useful is having weights on the float, because sometimes with the wind and with the currents, if it's not weighted down, it moves a lot. So that's what I found to be most helpful. And sometimes you might have, a 1 meter error if the current is too strong.
Great. Okay. Let's see. Another question coming in from the chat. Another question is about coral disease. In some cases, the signature of diseases is similar to coral bleaching. I'm wondering how you deal with this. I think that seems like that was something you discussed, I believe.
Yes, and that is for the for which method, or in general?
I think just in general, not specified.
Just in general, yeah. So that's actually one of the things that we're going to be testing out with the photo quadrant method, because the AI is not going to know if it's bleached because of a disease or if it's bleached because of coral bleaching. So I think this it's one of the limitations that we have, for example, with the photo quadrants. With visually, I think it's what we've done in the past, for example, in the Mar region, is that we do the method simultaneously to record disease. So if we see that there is bleaching and there's also disease, then we just try to have that number as a general percentage, but we also make a note that it's a disease like stony coral tissue loss disease or any other disease.
Great. Let's see. This question is there any criteria for selection of areas and what are they? Thank you.
Okay. I suggest we move to the next slide. And then if you can please repeat the question, Ben.
Yeah, definitely. Sorry. So the question is there any criteria for selection of areas and what are they? So I guess this might be selection of areas for surveying under any of the 3 methodologies you described.
Mm-hmm. I think it depends on your resources and also where you're based and how many people can also be with you and your team. So I think logistically, those are things that you have to think about. But if we go to the physical factors such as, that I talked about, like selecting different habitat types, different locations, and having replicates for, same depth sites in the same similar habitats, then those are other criterias. But I think it's going to also have and the specifically yeah, the location that you're in.
Makes sense. All right, next question is an interesting one. Could we use the ReefCheck survey method to collect data and photos and then use Reef Cloud for photo analysis?
Yeah, you can do combinations of methods. As long as you're taking the minimum criteria from each of the methods, you can combine. And I think it depends also, you know, if you want to use them just for validation, or if you also have another scientific question that you want to answer within your surveys as well.
Okay. Let's see, another one. This person asks about the rapid survey from WCS. Should we identify the macroinvertebrate observed in the quadrant?
In the quadrant, it's always we always want to have the most information, but for this method, we only have those 3 general categories. So I believe it's hard coral cover, soft coral cover, and also macroalgae. We are working to suggest abiotic covers. So for example, if there's sand or rubble, that gets documented so that we have a more thorough understanding of the benthic cover in general terms.
Okay. We have one that Chris would like to answer. This is Eureka from Indonesia. Reef Cloud and CoralNet seem to be similar. If we have used CoralNet before, can we simply import our data from CoralNet to Reef Cloud?
So can you hear me?
Yes, we can. Thank you, Chris.
So you can integrate those 2 platforms. What I'm not sure of, and I have to tell with Manu, if you have already analyzed data, if you get it into Reef Cloud to get the reporting, but I do think that's the case. But you can, for instance, the training data that you created in CoralNet can also be integrated in Reef Cloud, and then photos can be reclassified using that training data. And it would create a percent cover and benthic category for each benthic category. So not only the coral or bleaching categories, for each category.
All right, great, thank you. Let's see, our next question. Do you have any tips on what to do if we accidentally messed up with the photos when we were using the photo Transect, so that we don't miss any data or have blank spots in our observation areas? So I guess what to do if you are taking photos and some of them, or 1 or 2 of those are off somehow.
So the question is, what tips I recommend for a photo that has not been correctly taken, or?
I believe that's the question, yeah.
Okay, so if your photo is blurry, for example, and I would just suggest eliminating it, for example, because it's the program. Well, first of all, you manually are not going to be able to differentiate what the benthic cover is, and then the AI is not going to be able to do it. And if you've maybe gone a little bit further up on the plumb bob, let's say that, you know, centimeters, I think cutting the image will make will reduce that error. But I think it also depends on what kind of mistake is done to the image.
That makes sense. This person asks, should we also document bleaching in non-corals, giant clams, anemones, etc.?
I do think it's important. I know for the majority of the methods, the focus is on hard coral cover and identifying the percentage of bleaching on hard corals. But I do think that if many different invertebrates are indicators of bleaching events, so I would say to record that information as well. Maybe not throughout the methods because they don't include them, but as a note of your transect. I think it's quite important. For example, in the Caribbean, the invertebrate Palitoa, which is very common, it's an indicator that there's temperature changes. So I do think it's important to record.
All right. This is a question about a different program. So this person asks, have you tried to, oh, sorry, Andrea, I didn't mean to interrupt you. This person says, have you tried to use coral point count with Excel extension made by Kohler and Gill for analyzing coral bleaching quadrat photos? Some people in Indonesia are familiar with it, and it can also produce the percent coverage for each benthic category. I just want to know your thoughts about the program.
Yeah, I think coral point count is an excellent program, and it's been used many times before. It's quite common program, so I do recommend it as well. I didn't mean to exclude other great programs out there, but we just focused on just a few examples. So I think it's a great program as well, and it does provide good summaries that could also help provide the data for validation. Yes, and I think Chris can complement on that as well, if you like to jump in on that, Chris.
Yes, so thanks for that, Andrea. So coral point count is a very valuable program, and it has been used many times. I've done thousands of photos with it. However, the challenge of coral point count is that it's completely manual, where Reef Cloud and or CoralNet are actually a process where you almost do the same thing for a set part, the same thing as you do for CoralNet, but only for, let's say, 5% of all your photos, 10% maybe. And then the remaining photos are automatically analyzed using the training data that you created. So there's always a manual component in automatic photo analysis, but usually that's only on a small set of all the photos, where coral point count is only manual. So that requires more time as well.
I'm just looking for other questions. And again, feel free to plug your questions into the Q&A. That's the easiest place for us to track them, but you can put them in the chat too. I guess if it's an emergency and the chat is the first thing that you have and the only thing you have. Q&A preferred though. Let's see. This person asks, are there sites?
I was just answering a question to Steve Fisher.
Oh, go ahead, sorry.
Sorry, there's a little bit of lag. But yeah, I was just going to say that I would like to connect with Steve Fisher. I was just answering his question about how another type of method can be incorporated into the program. So yes, I would be glad to connect with you and see if it can be done and how it can be done.
Alrighty. This person asks, are there sites globally where you can rent, attend, or intern a field survey?
What was that question again? Sorry, Ben.
Yeah, I think this person is interested in participation, basically, where they can participate in a field survey. Yeah, if there's an easy way for them to do that.
Okay, perfect. Yes, I think it depends on what location in the world they are. And I would suggest for them to reach out to us via email, and then we can see the best location where we can link them up with different organizations so that they can help out with the surveys, or also with data analysis if they don't want to move, but I'm sure that they would like to get in the water.
Let's see. I'm just scrolling through. Let's see, a technical question. Got it. Okay. This person is asking about distinguishing causes of coral mortality from coral bleaching. Are there any indicators to know if corals are bleaching or if they're being affected by surface runoff that may cause discoloration that looks like it's bleaching?
Yeah, so when we have sedimentation or water runoff, it can be even just fresh water or also with sediments and chemicals. We can have bleaching from different water quality issues. So I think documenting it, depending on the information that you know about the site, if you know that there's an issue happening, or there's the rainy season and you start seeing bleaching, that sometimes you can differentiate it based on the moment it's happening. It may be hard if you have this situation and then also heat stress on top of that. So I think, yes, that would be a hard one if it's happening all at the same time, because it could be synergistic and confounding factors that might be affecting the bleaching.
All right. And then maybe piggyback onto that really quickly, there's a question about what about recording species like Drupella, black spot, and COTS to distinguish disease from bleaching?
So that's a good one. And I think I mentioned it in one of the slides of differentiating predators that can, leave marks from mortality, and then it can be confused as bleaching. I think when you're doing the surveys, it's important that you take a moment, not just to write down the information really quickly, but to make sure that you are looking throughout the area. I've seen it many times where you just look a little bit under the ledge, and then you start seeing all these snails, for example. I think to complement the methods, for example, ReefCheck does have it in its invertebrate survey. For example, the WCS one doesn't, but you can also make a note of that. And the most important thing is to not be able to account that as bleaching, being able to differentiate it.
Yeah, sounds good. I'm just looking through the most recent batch of questions that have come in to see if I can find some more. This is a fairly technical question, but this person is just wondering whether there are any cameras you recommend for the geo-referenced photo surveys.
Yes, we recommend the Olympus Tough camera. I've been through so many cameras throughout my my survey days, and I think I've flooded many ones too. So I highly recommend the the Olympus Tough, and it has a casing for extra protection because it can only go up to 15 meters. So if you're in areas where you might just be a little bit under that, I suggest to have the casing, and it's a very good camera.
Okay. Sorry, just looking through the questions.
I see that there's a question about, I will be delighted to cooperate in the Egyptian Red Sea. That is great. Please contact us, Ahmed. We would like to connect with you. We have connections in the Red Sea and different organizations that you can also link up. So yes, we'd love to connect with you. And then there's another one. Is it worth to invest in ROVs instead of having a diver do it, especially if you have limited experienced divers? I'd say if you have the money, I think ROVs are quite expensive. So it depends on the institution or the organization and the financial requirements. And so, but I think ROVs are quite useful for also deeper areas where where it's harder to reach due to the technicalities of diving deep.
This person is asking, reefs are not always flat. The plumb bob method restricts you to flat areas. Couldn't you use a 1 meter long section of PFC pipe on slopes?
Hi, Dr. Fenner. Yes, you are. Yes, I think the method can be modified to use the like PVC pipe. I think for the most part, it's a little bit more uncomfortable to dive with a PVC, but I've also done it many times in the Mesoamerican where we have a PVC 1 meter thick. So I think yes, adapting as it makes the method easier is always good.
Okay. This person asks, where can we collaborate or contribute in Queensland, Australia?
Oh, great. So, Julie, yes, there's many places that that you can connect with in Australia, many organizations. It depends which method you would like to use. But for example, the photo quadra method is in the University of Queensland. So I think that would be the closest one. I am sure you can connect with Chris and can help out somehow. And I do know that ReefCheck Australia is also doing some surveys. I am not sure if they're doing them in Queensland, but yes, please reach out to us and we will try to connect you to an organization where you can help out.
Well, I think that, oh, let's see, we have one more. Steve Fisher is asking how we can connect later to discuss, and I have that. Andre, I believe you flagged to talk about that now.
Sure.
I got his email through the chat too. Oh. And you can also move to the next slides that have the contact information.
Okay.
Perfect. Yeah, I was just going to mention that. There are some other resources that you can further look into if you're interested in learning more about the Island Core Atlas and remote sensing. There's the Reef Resilience Network course. We also have other workshops and information in the YouTube channel and new workshops coming up soon. And then on the next slide, I believe there's the contact information. And then we have a poll also that we can do. All right. So before we go on to the contact information, so we're interested to know what methods and what platforms are you most likely to use. Quite curious about that. And we would like to know if you feel ready to monitor a coral bleaching event. And if you are, if you have the resources you need, or if you want but lack financial support, or if you are lacking trained people to do it, or not planning to monitor a bleaching event. So we're getting the answers in. We'll give it a minute. I guess in the meantime, I would just like to follow up on the question about the soft corals. And it's been also a question that I've had many times discussed with the remote sensors scientists, remote sensing scientists, to see how important it is to measure soft coral and the percentage of bleaching, and if that's able to, if we're able to see that from satellite images. So I think that's something that I still haven't had the answer, but I think if that it's a good idea that for us to consider that percentage and then be able to validate it and see if we can actually see it from the Sentinel images. So thank you. All right, and I think we're pretty much have most of the answers. So we kind of have a tie or, all right, we're sharing the results now. Thank you, Ben. So we have sort of a tie between the Bell Transect ReefCheck and the rapid bleaching protocol from WCS. And then a higher percentage, 45% for the georeference photo quadrats, and 35% of the participants are ready to monitor and have all the resources need, but 47% do want to monitor but lack the financial support, and about 25% lack the people who are trained to do the monitoring. So thank you very much for sharing. So here is a slide with our contact information. We are also interested to know where bleaching events are occurring currently. So if you have observed bleaching in any of the locations that you're in right now, please let us know via the chat. We're very curious to track the bleaching spread. And thank you very much for joining us. This is the information to contact us. We will be also following up with the recording of this training and share it with with everybody and that was not able to join, and also the ones who want to share the information further. So if you'd like to let us know if you have seen any bleaching in anywhere in the world where you are, please let us know via the chat. Thank you very much. Getting all the thank yous.
And Chris, did you want, I see you're typing the answer. Did you want to answer the question about volunteering for remote sensing or GIS?
I think Chris is typing it. Or is it? Yeah, I wasn't typing it. I think it's Chris.
Yeah, I know. Yes, it does say that, but it has for a while. So I just. Oh, he did. Yeah.
Okay. And have we gotten anybody to tell us know if there's bleaching in their locations? I don't think so. Thank you for hosting this event. Looking forward to putting these methods to use. Great. And we have another comment for Queensland, Australia folks. The Great Barrier Reef Marine Park Authority has the multi-tool Eye on the Reef program with 4 tools, 3 being underwater visual surveys that includes photos since 2012. And it is in early stages of being integrated into Reef Cloud or photo analysis. That is great, Chris. We would like to connect with you to learn more about the tool. I have seen the app. So yes, I'd love to connect with you further on that. If you can send your email, that would be great.
And thanks also to those of you who are putting your bleaching locations in the chat. That's really helpful. So if before you leave, you've seen bleaching, let us know.
Perfect. Perfect. I saw very little bleaching in Indonesia 2 weeks ago. Okay. In Brazil, last event in 2020. Okay, thank you for sharing. Yes, we're very interested to know where bleaching is occurring currently in the Pacific. We're trying to follow social media and also informal observations of bleaching, because we would like to, coordinate with people on the ground to see how bleaching can be monitored in different areas. So it's always good to have a heads up on where, paling or bleaching is being observed. Perfect. Okay, Western Australia has seen some mild bleaching. Okay, that's interesting because I did see that there was a lot of heat stress concentrating in the area. So thank you for sharing. Okay, well, thank you very much for everybody joining in. I really appreciate your support, and thank you for those who stick through it. And thank you, Ben, for helping me with the my technical difficulties with the internet and all my internet backups. But thank you everybody for joining in. Thank you, Helen, as well, for all your support, and every other of the participants, Chris, for helping answer all the hard questions and helping answer the questions in the chat. We had a lot of them. So thank you very much for your participation, and have a great rest of your day and good evening to the people in the Atlantic. Thank you.